Today's lesson is a continuation on section 4.2, graphing linear equations, and we're really still graphing with limited domains like we were doing in the previous lesson. I'm just going to go through a few examples here to kind of refresh our memory and show us one thing I didn't talk about the last lesson, something that can happen with the domain, how it can be limited in two different ways. You can have an upper boundary and a lower boundary for some problems when you're trying to graph an equation. So we'll look at an example like that too. But first, as kind of a review, here's what we were talking about last time. We were graphing an equation that had a limited domain. So here's our equation. Y equals 3x minus 5. But then it says that we only plug in certain values for x for this equation to work. This domain says x is less than or equal to 3. So when I plug in numbers for x, my domain down here in my table, I have to plug in numbers that are, as it says, 3 or less. So as I recommended in the last lesson, if you watch that one, first what I should do is I need to first sure plug in that boundary. I need to plug in 3, and then now think of numbers that are, well, in this case it says x is less than or equal to 3. So the x values I'm talking about have to be less than 3, so maybe like 3, 2, and 1 would be good numbers to plug in. I could plug in 0, I could plug in -4, I could plug in some other numbers, but I'm just going to pick the numbers that are right around 3. So I'll plug in 3 for sure, because that's the boundary, and then 2 and 1 will work also. Now I'm going to plug these in, I'm going to find my y-coordinates and get ordered pairs, just like we did when we first started this chapter, so that part, again, isn't too much new. If I write this out and put y equals, well, 3 times whatever I plug in here, 3, and then minus 5. I'm going to plug these numbers in, see what I get. 3 times 3 gives me 9, minus 5 would give me 4 for the first point here. If I plug in 2, 3 times 2 gives me 6, minus 5 gives me 1. And 3 times 1 gives me 3, minus 5 gives me -2. So here are my 3 ordered pairs, 3, 4, 2, 1, 1, -2. I'm going to start plotting these. 1, 2, 3, 1, 2, 3, 4. Sorry, oops, it's over. Oops, I mistaken myself there, if you caught it. 3, 4 means I should go to the right 3 and up 4. I did catch myself there before I went too far. 2, 1 means the right 2 and up 1. And 1, -2 means right 1 and down 2. So good. So there's my 3 points. Now again, we talked about this on the last lesson though. I plot these 3 points, and usually, if we were just graphing an equation, graphing a line of an equation, I would just draw some kind of line, and that's not a very good one, but I would just draw a straight line through both sides and put arrows on and say my solutions go on forever in both directions, and there'd be the graph of that equation. But when I'm graphing with a limited domain, what it's saying here is x has to be less than or equal to 3. Well, in the x direction along the x-axis here, 1, 2, 3, here's 3. Here's where x equals 3 up and down this particular line. So it's saying x has to be less than or equal to 3. I can't have anything that's this direction, anything greater than 3. So my line then must start at this green point here on 3 and then go this direction to the left. In this case, it's kind of more down slanted, but either way, it's still to the left. That's the way I have to go because I can't have anything to the right of that dotted line where x equals 3. So there's what my graph looks like for my limited domain problem here that I have so far. Again, just like a bunch we worked out in the last lesson. The last thing I have to do in this problem, as it says, is identify the range, which is the possible y-coordinates I can get in this equation. Well, again, if I look at now when I'm thinking about the y direction, switch your mind to thinking in terms of the up and down direction. Well, here's the uppermost point on my line, on the graph that I have here. And if I look at that, well, here's my y-axis. That is at 1, 2, 3, 4. So I'm up 4 here. So if 4 is my topmost points and it's everything below that, then I should think that, well, all my y values I need are less than or equal to 4. So there's my range. All the y-coordinates I'm going to get from that graph are 4 or less, so that's the range that works. So again, we did some of these on the last lesson too. If you're still having trouble with these, maybe check out that previous lesson as kind of a review, but here's kind of also a short review in case, just kind of to warm up for the newer problems today. So today in class, I'm going to talk about some of the problems that were on the previous assignment where there actually was a domain that looks like the one we have in this problem here, and it's just a little different. On the previous problem, just kind of flipping back to that one, I had x is less than or equal to 3. So that just meant all my x values have to be less than 3. Well, this domain, like I said, it looks a little different here. It says domain is x is less than or equal to, or 0 is less than or equal to x, which is less than or equal to 4. And as I tell the students, this kind of looks like what it is. It's saying that all my x values are between these two numbers. I can't have anything bigger or smaller than those numbers. My x values have to be at least 0, but can't be more than 4. So it's those numbers and anything in between that. So I actually have boundaries on each ends of this domain. Well, if you remember back when we first started talking about these limited domain, I always said plug in the boundary first as a starting point. Okay. Well, same thing here. I'm just going to put both these numbers in. I'm going to put 0 in for sure, and I'm going to put 4 in for sure. And then I just got to pick some number in between that. So let's say I'm going to plug in 0 here, and maybe my biggest value will be 4. And then I just got to pick some number in between, and right in between those is 2. So here's numbers that I'm going to plug in. Our graph will also look a little different since there's boundaries on both ends of this domain, but I'll talk about that in a second, what it looks like. First, let's just plug these numbers in and see what we get. If I plug in 0, so this equation looks like y equals, well, 0 minus 1, that'd be negative 1. If I plug in 2, 2 minus 1 just gives me 1. And if I plug in 4, 4 minus 1 gives me 3. So there's my 3 y coordinates. There's my ordered pairs, 0, negative 1, 2, 1, 4, 3. 0, negative 1 means left to right 0, down 1. 2, 1 means right 2, up 1. 4, 3 means right 4, up 3. So there's my points. So, as I was kind of illustrating on the previous ones where we had a limited domain, here's what I'm going to think about for the graph of this one now. I'm saying that the x values have to be, they can't be any less than 0, and they can't be any greater than 4. Okay, so again, here's where along the x-axis, 1, 2, 3, 4. Here's 4. Okay, I can't have any x values that are to the right of this line because that'd be greater than 4. So I can't have anything over here. So this area is out. Also, I can't have anything less than 0. Well, here's 0. I'm going to go in. That's right along the y-axis actually, but I can't have anything that's less than this. So this area is out. I can't have anything over here. So where's my line going to be? It's actually just going to be from this point on 0 to this point on 4, and that's the graph right there. When I have a limited domain problem where there's boundaries on both ends, well, the graph shows that. I can't go any farther right than that graph, and I can't go any farther left because I can't have any x values that are in those areas. So what do you know? I don't have any arrows on either end of the graph, which is why it's maybe a little different than usual. But that's the graph right there. It actually is kind of a connect the dots. I can't go any farther left than this point, and I can't go any farther right than the farthest right point, so it actually ends up being a line segment. It's actually called a line segment, and we'll see if I can spell it right. I think it's pretty easy though. A line segment, okay, where I have points on both ends of the line. So, but the other graphs we had in the previous lesson were rays. Line segment looks like a line with points on both ends, again, boundaries on both ends. So this is what's going to happen when I have some kind of domain like this that has boundaries on both ends. What will the range look like? Well, it will look similar then. Again, notice how I have y in the middle here. Sorry, x in the middle here. X in the middle, and then I have inequalities on both sides of it, and then I'll have some boundaries. Okay. Well, if I kind of start that down here, I'm going to have y. All my y values are in between my highest and lowest points. So I'm going to have something kind of like this. I'm going to have a number right here and a number right here. Or actually, maybe I can even show that with circles. I'm going to have a number in this area right here and a number right here, whatever those two numbers end up being. But those are going to be my highest and lowest points in terms of the y direction. So if I'm trying to figure what those points are, well, again, here's the y-axis. Okay, I'm just going to get those arrows out of the way for now, so they're just a little bit in my way. Here's the y-axis. Here's my highest point right here of the graph, and here's my lowest point. I'm just trying to figure out where those are. Well, my lowest point looks like it's just down 1 from the origin, so that's just negative 1. So that's going to go on the left side of that inequality there. So since this is negative 1, there's where that goes. My highest point looks to be 1, 2, up 3 from the origin, at where y is 3. So that's going to go right here. So y is 3, and that's the two boundaries, the two endpoints of this particular graph. I can go as low as negative 1 on the y direction and as high as 3. So all my y values on this graph must be between that because they're in between those two points. So again, just a little bit different than the ones we did on a previous lesson, but Still similar to what we've been working on here lately in terms of the boundaries, and now just a little new idea. I can have boundaries on each ends of my problem. We'll do one more limited domain problem here as kind of an example, and we'll probably go look at some in classes together as well. This problem says graph the equation y equals 1/2 x plus 2. The domain is -4 is less than or equal to what x is, which is less than or equal to 12. So again, I have two boundaries in this problem, -4 and 12. Those are my highest and lowest numbers. So in this case, I can't go below -4. I can't go above 12. So I'm going to plug those two boundaries in for sure, -4 and then 12, and then just some number in between. It doesn't really matter what the number is. Sometimes I just like plugging in 0 because it's an easy number to plug in. So I'm just going to put that number in there. So just to have 3 points and see that they fall in a line. Now I'm just going to put those numbers in, just like I usually would. 1/2 times, well, whatever x is, plus 2. So in this case, I'll put -4 in, see what we get first of all. If I put -4 in, half of -4 is -2. Plus 2 actually gives me 0 in this case. So I plug in -4, I get 0. If I put in 0, 1/2 times 0 is 0, plus 2 gives me just 2. And if I put in 12, half of 12 is 6, plus 2 gives me 8. So again, I found 3 ordered pairs. I definitely plugged in the two boundaries, the upper and lower boundary, because I need to know where those points are. And then just some number in between, and we'll see how they line up here. -4, 0 means left 4. Up or down 0. 0, 2 means left to right 0, up 2. And then 12, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 11. Oops, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I was thinking ahead of myself there. And then up 8. 1, 2, 3, 4, 6, 7, 8. I'm almost off the graph here a little bit, but should be somewhere about right there. So that's close enough for me. If I'm going to draw a graph of this here, again, my x values are the left and right. Or x values are in terms of left and right on the grid. There's my x-axis. I can't go any farther left than -4, and I can't go any farther right than 12. So in this case, where's my graph? Well, it has to be just connecting these points, essentially going through that middle point, and then connecting the 2 points on the edges, and that's my graph right there. It is boundaries on each ends. So again, this is a line segment in this case. That's what I'm going to get. Just kind of erasing the x, my x boundaries there, so now I can look at in terms of my y direction. But again, I think that's what the graph's going to look like. I'm going to look at the y direction so I can calculate the range. Range, R colon, and my abbreviation for it. Well, if I try to think of the range, I got to think in terms of the up and down direction here. There's as low as my graph goes, and here's as high as my graph goes. So where are those lines at? Well, it looks like this is just at 0, so 0 is my lowest point. That's going to be less than or equal to y, which is less than or equal to, it looks like my highest point is just, it looks like 8. Because when I plugged in 12, I got 8. So that's my highest point. So here's my range. The graph goes as low as 0 in terms of the y direction and as high as 8. So again, these problems, again, take a little more thinking than maybe some of the ones we've been doing in the past, just because you really got to look at the graph. You know, see where you are in terms of my highest and lowest values, or my most left and most right values. These limited domain problems, but I do like these because they do make us think a little bit, make us work, but they're good thinking problems for what we're working on right now. And if you can understand these, you can do a much better job. You can definitely understand how to graph any other equation as well. So.